Bismillahirrahmanirrahim. Hi, good morning, or maybe good afternoon to everyone and my lovely teacher. My name is Muhammad Anik Lukman bin Aris, and today I will be presenting my work, which is for computational thinking in mathematics course with code MTS 1142. My presentation title Unlocking Efficient problem solving in non-routine mathematics problem using computational thinking and the Polya model. So let's go through. Before we start, I want to tell you guys that here we will learn a lot of things. So just enjoy the adventure because we will learn what is non-routine problems, and then second, what is computational thinking, problem solving framework. The fourth is the strategy 1, the strategy 2, comparing efficiency and the results, and discussion, also conclusion, and lastly we are got a lot of things here, that is the reference. So let's go. First of all, let's define our challenge. That is a non-routine problem. Do you guys know what is non-routine problems? No, right? So I will tell you guys about it. Non-routine problems is a complex task that requires creativity and originality, as there is no immediately apparent strategy. So we're gonna think, and think. Our specific problem is involve 100 bottles. Number 1 until 100. One of this bottle is poison because someone else put it. The factor is I'm very handsome. So he put the poison there. So to help me, we have only 7 testers available and must identify the correct bottle within a maximum of 5 attempts. So let's go. How we gonna solve this? Yeah, you know what? I'm very scared. Where is the poison? And how if I gonna drink it? So this is the way how to help me. To solve this, we integrate two powerful frameworks, which is the Polya model and computational thinking techniques. The Polya model was created by George Polya. His model provides a four-step structure, which is the understanding the problem, devising a plan, trying the plan, and lastly, revisiting the solution. Okay, did you understand that? Let's go through for the computational thinking techniques. Yo. So we can just rely on the poly model to help me. We can make it more efficient with we complement this with the four cornerstone of computational thinking of mathematics techniques. So you know what? Later we will see two strategy how to help me find the poisonous one bottle. And this is the example how we apply the computational thinking, which is CT, in our strategy. So let's go through. First of the cornerstone is decomposition. In the example, we breaking the large group of bottle into smaller tasks. Okay? And second of the cornerstone is pattern recognition, where we finding trends or structure. In the example, we identify binary patterns and powers of two. And third is abstraction, where focusing on the important data, we just go away that's data that not important, like that lah. So on this example, for strategy 1 or strategy 2, we focusing on group data rather than individual bottles to make it more efficient and fast. And lastly, the cornerstone of the city is algorithm design, creating a step-by-step process for the solution to make it more structural. So we're creating a systematic step-by-step testing process. All right, and then we're gonna through for the strategy 1 and strategy 2 to make you guys more understand this thing. Let's go. This is why the non-routine problem be interesting. Because why? It is can be solved with a lot of strategy and can solve it more better, more greater, more efficient with apply what? Before this we say two things. Yes. It's the city computational thinking techniques and the Polya model. For the strategy one, we're gonna do the group testing method. It's a traditional method to know where is the poison. Please help me, guys. So, first of all, our first approach is the group testing method. Here, we apply the composition by dividing the 100 bottle into 7 groups because we have 7 testers. These groups range from 1 to 15, and the second group will be have the 16 to 30 bottle, the number of the bottle, and then go through until the 7 tester will have bottle that number with 91 until 100. And then when we carry out the plan, each tester trials one whole group. Yes, he go through drink it. For example, if a tester from group 34 until 45 is get 6, we have successfully reduced our search space from 100 bottle to just 15. Alright, do you understand that? And then, so we have smaller, it we know that the poison is from the bottle that number is 31 until 45. So for the second atom, we further decompose that group into smaller set of 2 or 3 bottles by, and then we gotta do the same process, test it, and by the third atom we will identify the exact poisonous bottle. Yes. So in revisiting the solution, we see this method is much more efficient than retesting bottle one by one. We cannot fool the atom. We just have 5 atoms. So if we try one by one, oh my god, it's will eat a lot of time. However, it is a multi-stage process that relies on waiting for results from one round before starting the next. So that's the strategy one. Let's go for the strategy two. I'm very happy because to help me, we have the second strategy. Yay! It is what it is. Do you see the name? If you don't see, I will tell you guys the name. The name for the second strategy is binary encoding. It is, and now let's look at more advanced new strategy, the binary encoding method. This strategy treats each tester as a bit of information, since a tester can only be sick, represent as 1, or not sick, represent as 0. 7 tester give us 2 power of 7, which is 128 possible combinations. This is more than enough to cover our 100 bottles. The tester also will be have the unique number, which is the power of 2 number. Alright, so how it works? We assign each bottle a unique binary code. For instance, we're gonna say that the poisonous bottle is bottle with number 37, and it is the addition by 32 plus 4 and plus 1. So its binary code is 0 1 0 0 1 0 1. This means bottle 37 is mixed into the sample for tester 1, tester 3, and tester 6. Instead of multiple rounds, we only need one round of testing. We simply look at the pattern of who gets 6. If tester 1, 3, and 6 fall ill, the binary pattern 0 1 0 0 1 0 1 tells us immediately that bottle 37 is the poison. This uses pattern recognition and logical reasoning to convert that binary pattern back into the bottle number. Okay? Did you understand that? If yes, let's go. You know what? I don't care anymore about the poison because there are a lot of strategy to help me identify where is the poison is. So now we will comparing the efficiency and the results about these two strategy. To sum up, what I want to say is when we compare the two, group testing is simple but can be slow. However, the binary encoding is advanced and highly efficient, completing the task well within our limit, which is 5 atoms. That's all. So, this is our last discussion and conclusion. But don't be too sad. So, we're gonna do for discussion one. That's computational thinking transforms complex non-routine problem into structured algorithms. It's help us to make the problem be more better to be solved. And then for the conclusion one, by using binary representation, we optimize our resources to achieve the highest quality result. And this is my final thought that if we combining Polias model with computational thinking techniques, it's allow for high quality, accurate problem solving in real world context. So use it, don't waste it. Okay? Wait guys, wait. And this is where you guys can find all of this thing and read it, use it, and again, don't waste it. Assalamualaikum and good morning or good afternoon. Bye.